Hello everybody, here I have another patient to fix. This is a nice power supply, 1 kilowatts. A guy brought it to me and said that when he tries to turn it on, its breaker turns off. So probably we've got a short on the primary and maybe some shorted switches or whatever it is. I always connect SMPS through isolating transformer, and also I use the light bulb. As you can see, now I turn it on and the light turns on, so it clearly indicates that we've got a short. Just for the record, I'll try to use my tester to see whether we have or not some standby voltage, but we don't have because the LED doesn't turn on. So we clearly have a short on the primary, and that's what we should check out. So by the way, it's COUGAR SMPS, never was opened. We've got an original seal in here. So we are gonna be the first who's gonna go inside of this beast. So now I'm gonna remove 4 screws. I removed it, as you can see, and that's the first time that power supply is opened, and inside we can see a lot of dust and dirt. Not the good side. So before moving any further, I'm gonna blow it somehow, clean it properly, and only after that I'm gonna do some measurements, stuff like that. Okay, I cleaned it. Now it's much better. Let's make a visual inspection, and by making it, I don't see any blown components, nothing obvious on the first side, at least from this upper side. Those switches are good, nothing blown. Sometimes when they blow you can see a burn mark or something. We know that the fuse is good because our light bulb lights up. So this is the primary side, and we have a problem somewhere in here. In order to check it, I removed the screws already. Now I'm gonna make some measurements and let you know what I find. From this side, also nothing blown, at least from the first side. All components look good to the naked eye. So far it is unknown what is the problem with this guy. Now I'm gonna get my multimeter, test the elements, but before I do so, as always, discharge the capacitors. Here in this stick I've got a 1 kilo ohm resistor, and I always do this, and I definitely recommend you to do this, because believe me, you don't want to be hit by that charge the capacitors might contain. It's really an unpleasant feeling. By the way, the power supply is really good, not the cheapest. It weighs quite a lot, so maybe it's not 1 kilowatt, but I think it's close to it. First of all, we've got to check the primary switches, transistors. Usually they shorts more often. This is the most common fault on the primary side: shorted, blown transistors. 70% probably, or maybe even 90% of time we've got it shorted. And if you want to replace one of the short transistors, you've got to replace all of them in the line, and they've got to be the same like in the original one, or you can check it out and find an analog. Okay, I was wrong that we don't have any blown components. When I examined it better, I've noticed one blown resistor through my microscope. I'll try to show you how it looks like. It's not the best view, it's not a digital microscope, but anyway, just to let you know, here is the dot inside, and you don't have any marks on it, any numbers, but probably it's 20 ohms resistor, so I need to replace it after. But now we've got an indicator when we know that the resistor in the gate of one transistor is blown, so it's definitely we've got a blown transistor as well, because resistor didn't fail by its own. So as you can see, we've got a short everywhere, on the bridge, on the output side, plus and minus DC side, on the transistors, everything is shorted. So that's obvious that we've got to remove at least one transistor. It's not an easy job to do. In order to remove it properly, you've got to remove all the components that sits on that thermal shield. Here are some diodes as well, and other transistors. This transistor is good. It's TO3 package. It's a bigger one. It's looks like a good one. But those two TO 220 sits on this plate, and I'll try to remove it by removing one of the big capacitors, and probably I'll be able to reach those transistors after removing those caps. But as I said, it's not an easy job, so it's really understandable why repair centers don't want to work with power supplies. So now when I removed the capacitor, it became more obvious that we've got a blown component. Now I can see some smoke, some even crack on the transistor and the capacitor. We can see where the magic smoke came to and left its trace on the big cap, as you can see. So this transistor is definitely blown. I'll try to replace it, and if we still have a short, so probably other transistors are also bad. But before I replace it, I need to unscrew it somehow, because if you don't unscrew it, it would be really difficult to hit its legs and to desolder it. On the picture you can see the crack on this transistor, so the crystal is clearly blown. When I removed it, the short is still there. So you can see this line is still shorted, like completely shorted. So unfortunately, other transistors, probably some other elements, are bad. This one is 18 amps, 50 volts, 500 volts, sorry. And two other transistors are also the same. So as I said before, if we want to replace them, we've got to replace all of them. Sorry for the delay, I was a little distracted. So now I'm gonna turn on my soldering iron again, and as you can see, I desoldered all those components. It's two transistors, one diode, and one fast diode as well in the package of TO220. All those components were shorted. Now there is no short, and probably if I find replacement for those components, the power supply still have a chance to be repaired and not to go to the parts or even to the trash yard. So as you can see, by the way, this one that was cracked, don't actually short it. It's not shorted, it's open circuited. Source and drain is open circuit, so the crack made it open circuit, no short, absolutely. So you have to keep that in mind, that sometimes these transistors not fail shorted, but they fail open like this, and it really can be tricky in repair. You can check it on the PCB. You can see some diode drop, but not through this transistor, but through some other passes. So it really can be tricky, faults like this. Okay, I found the replacements. This one only is the same, like exact match. It's 5436 or something diode. These are not the same. As I said, those were 18 amps, 500 volts, but here I have 20 amps, 600 volts. At least our friends from China quoted it like this. Let's hope that They are honestly said that, but I don't have other choice, and I'm gonna put them because I don't have the exact match, the original match that I could trust. Anyway, we've got to try. We came too far, and so I tried to put it back, everything, and the hardest part was not actually soldering it, but screwing those screws tightly in this close area. But I managed to do this, and now we're gonna try to turn it on for the first time after replacement of those components. If it's not work, so probably the control board is bad as well, and that would be really bad. But what can you do? Sometimes this happens. So now I'm gonna turn it on, and what do we see? And we see nothing yet. Okay, we see the green light on my tester is present. It means that we've got standby voltage, which is kind of success. But when I try to turn it on, here I have 3 indicators, 12, 5 and 3.3 volts, and we've got nothing on the output. Only standby voltage. So unfortunately we've got another problem, and I don't really know what to do next. Probably I'll try to desolder control board, see what the IC is there, and trying to find a replacement IC. I've got several of types laying around. Also, I'll try to see whether do I have anything on the outputs of that IC, some triangle or something like this. So, by the way, at the beginning of the video I told you that we've got a blown resistor, 20 ohms, and there were 3 of them. I decided to check it, and here I see 19 ohms, and then I tried to check the blown one, and I checked it, and 19 as well, but I didn't notice the key letter, so it was actually 19.86 kilo ohms, but I decided that it was 19 ohms, and that fooled me a little bit, and probably this is the fault that stops us from starting the power supply. So I replaced the resistor, and as you can see, I'm trying to start it one more time, and I forgot to turn it on, of course. That happens sometimes. So now we have standby voltage, and when we turn on the bottom, and we have nothing. Though the resistor was blown, but the replacement didn't help us to repair the power supply. So I have only one option, unpleasant one, to replace the IC, the control IC. This is actually the last hope sometimes when you've got problems like this. You decide, okay, let's try to replace the IC. Maybe when the spike came through those transistors, it hit the control IC. So sometimes it helps, and sometimes really those IC dies, and it is kind of tricky to find the fault because you don't know to which leg the spike came or what damage it caused. So it's really, even sometimes you have some signal on the output, some sawtooth or something like this, some square wave, but not always. I've got those ICs, but the control board and the elements on it looks all intact, so probably the original IC is good. But anyway, I'll replace it just to be sure that it's not the IC. It's not an easy job, not the pleasant one, but what can you do? When you come so far, you don't want to quit. Okay, I replaced the IC, I tried it off camera and it didn't help. I was even in a mood to give it up, but then I decided to check transistors, little one that actually drives the gates of the transistors, the main transistors, through the some secondary transformers or some driving transformers, and as you can see, one of them was shorted, both sides. One was good, one line was good, so there were two transistors on one line, on one shoulder. As you can see, the culprit. I found the replacement one from a similar power supply, put it back, four of them, and here is the last chance. If it's not powering on, I would give it up. I'll give it back to the customer, like no fix, and of course I won't get any money from him because this is my credo, like not to take any money if I don't have success. As always, we've got the standby, and now we've got the output. It faded away because I turned it on through the light bulb, and there is not enough current can pass through this and to charge properly the capacitor, so it's randomly flashing. So this time I removed the light bulb from the line, and as you can see, the outputs are present: 3.3, 5 volts, 12 volts. This is my DIY indicator, very easy to make, so I recommend it to make it for fun. Also bought this cheap tester on eBay. It's useful to show people, to customers, whether its power supply is working or not, whether voltages are present or not. So also I can recommend you to take it. As you can see, 5 volts, 12 volts, 3.3, actually 3.4 without any load. This is good. So all the voltages are present, and we did it. After all this time, I think you are getting bored with this video already, but it actually takes a lot of time. This is a short version, but it took me several hours to make it. So this is my mess: power meter, the power supply itself, the tester, the multimeter, and here we can see two big resistors, 1 ohm each, so in parallel it gave us half an ohm for 12 volts line, even less probably. Okay, now I put it on the power. Now we see all the zeros. I turn it on, the fan, and my tester takes about 16 watts. So now I'm gonna connect the load. I don't have much or less load or much load, less resistance, much load, and as you can see here I can load it only 150 watts, something like this, but made by experience this is always enough to understand whether the power supply is gonna work or not. So if nothing blown, nothing smoked, this tells us that the power supply is fixed. By the way, I connected not through the light bulb, not through the isolating transformer, because my transformer is only about 100 watt, so that was full line voltage, and if something happened that would be really huge. Some sparks, maybe my breaker would turn off all the light. So sometimes this also happens, and you can work on the device like for several hours, and then you connect it to the mains and connect some load to it. Sometimes it fails even with 100 watts load. This time it didn't fail, so we have got it fixed, that's for sure. I hope the owner would be happy to get it back working. So that's it for this guy. I hope you like it. Stay with me, and I will see you next time. Bye.